So hello everyone, welcome to this lecture. So all these days we have been learning about modeling numerical data for finding fraud and fraud patterns, right? So what if we leverage unstructured data like text or images or any other complex data, right? So let's start with text, and that's going to be the context of this week's lecture. So we are going to look at how to use text data to model fraud, and we have another instructor today, and thank you Ravi, thank you for joining us today. So Ravi has worked extensively in using text data for identifying financial fraud in the world of anti-money laundering, credit, transaction fraud, and many things. So maybe we would like to learn from Ravi's experience as well in terms of interesting case studies. So thank you Ravi for coming. So Ravi, I have some questions for you just to understand about text and fraud, right? So could you give some examples of how can we leverage text to find fraud?
That's a very good question to start our conversation today, Mahesh, as the flavor of the week is actually dealing with text in identifying fraud as a part of our course. So, let's take a classic example of today's world. There are multiple applications which we are installing in our mobile phones, be it for e-commerce shopping or for performing many UPI transactions or any search sites where we are entering our credentials, be it with respect to email ID or mobile phone number, etc., and creating an account. Now, take the case of an example of an e-commerce website which is having a sign-up bonus. So, being a user, if he wants to abuse the system in place, he can create multiple email IDs and create n number of accounts to get that particular discount or bonus n number of times. So, from the company's perspective, it is n number of customers who are actually using their website. However, in reality, it's the same guy who is abusing the system with n number of uh, digital entries. So this is one of the classic case of fraud which multiple companies are trying to deal with in the digital space, wherein the customers have multiple digital avatars against one real avatar. So that's one of the place where we use text a lot in identifying whether the customer is the same person or he's a different person. For example, going back to the example of an e-commerce website, he might have created n number of email IDs, but if you look at the address to which the products are getting shipped to, there's a possibility that it might be to the same address. So that's one way of identifying the fraud, where we do use text a lot.
Thank you Ravi. I think that's a great example. So one other question that I have is, let's consider something that's more specific to e-commerce. People buy products across the world. They make payments across countries, and there could be some regions that has some risky merchants, right? So could we also use things like product title, merchant title, or context? Whenever we are making a transaction, we type remarks, right? So context information like text put in the remarks. So can we also derive intelligence from such sorts of data?
Oh, that's a good question, Mahesh. Not just e-commerce. Let's take a classic example of sending money from sending money from a country like USA to India. So a person would have initiated a transaction, the originator, with a bank A in USA, where a customer B will receive it in his bank, bank B in India. So in this process of sending this wire transaction, a SWIFT message gets generated. The SWIFT message essentially has all these fields: the origination bank and the originating customer, the intermediary financial institutions who are facilitating this particular transaction, and the final beneficiary to which the money is getting credited. So among these fields, which is essentially our text data, because the bank name, the customer name, the financial institution's name, the address, the cities in which these banks are located, is entirely text data which is coming up. So we do have, let's say in your case of your example where you had mentioned rightly about risky merchants. Similarly, each financial institution has risky customers who are sanctioned customers whom the financial institutions are not supposed to deal with. So they are again essentially text data. So where we kind of do a cross reference between the existing information with which the financial institutions should not do a transaction with the people with the upcoming transaction and see if any fraud is involved or not. So that's one classic case where we use again text analytics to identify the risky customers. And similarly, what you had mentioned about the remarks columns, yes, even remarks columns play a key role, because essentially remarks column is a column where customer enters some details about the transaction, and especially with the cross-border transactions where ships or vessels are involved. There are cases where fraud or money laundering was identified when these vessels have stopped at ports where they are not supposed to do. Essentially, a sanctioned country where the vessel had stopped for a while.
So that's very nice, and thanks for explaining that, Ravi. And so now, when it comes to text, you cannot use that text directly, I guess, for modeling, right? So you might have to do some sorts of pre-processing to the text. So could you recall some nuances generally that comes with these type of data, and what could be some of the remedies that we could take care while pre-processing the text? I think in the numerical world we do outlier removal and all those things, right? Scaling. So what are the analogous things in text as well?
Well, yeah, just like numerical data, how you had mentioned how we deal with outliers, etc. Even text has to be cleaned up. I mean, forget about the system. Text data is something where even the users find it difficult to understand sometimes. So a lot of pre-processing steps do happen in preparing the text before it gets converted or before it acts as an input to a model. So few of the steps which I can think of right away are the first one, cleaning up the mess in the text. For example, removing special characters or removing foreign characters, and converting the text into either uppercase or lowercase, essentially having the same case across the text. Then we do have stemming and lemmatization, basically condensing the text into the root forms. For example, let's say machine learning. If I'm trying to do a lemmatization on that, we'll just have a machine space learn. So uh, stemming also does the same thing, but issue with stemming is it does not take the it does not get the meaningful word after it had condensed the existing word. For example, caring word might get converted to car when I use stemming, but whereas when I use lemmatization, we get the exact context of the word. For example, caring gets converted to care, care. So as you can rightly guess, when we have a lot of text to process and we don't have much of time, we go for the stemming exercise, but which is not ideal because it does create some words which are of no meaning. Whereas when I have time as an advantage, I'll be definitely using lemmatization, because where I'll be getting a meaningful context of the word which I'm using.
Okay, great, great. And one last question I have is, as you mentioned, pre-processing is very important in the world of text. So once you have pre-processed that text, we have to convert them into features or variables, right? Because at the end of the day, supervised modeling needs some x variables, and it relates to a y, and it tries to map the pattern. So converting this text to features, let's say there are various techniques and we could do it, but how to see it from an unsupervised point of view? Because let's say I don't want to convert text to features, I just want to cluster it or segment it or find similar text, right? Something like that. So how does that work?
A good question, Mahesh. Converting text to features. I mean, essentially, they have to be converted to some numerical form for the model to either perform clustering or grouping similar words. So, one case which I can think of is converting the word into vectors, where the vectors can be used to calculate the similarity distances by using maybe cosine similarity, which will be taught as a part of this particular course. Or as you had rightly said, even the distance metrics. Let's take the classic example of Levenshtein distance. So essentially, if there are two words, Levenshtein distance will tell us how many edits the second word has to be made. I mean, how many edits have to be made in the second word to make it equal to the first word. So the distance metrics are also one of the key ways to kind of identify similar words. So, and on top of these features, if we're going for unsupervised learning, which is the flavor of the day, we do get the word embeddings, which will be used as a part of building our neural network. So in this way, there are multiple ways of converting text to features with which the models are built depending upon what the objective is. If the objective is to kind of group similar words, we use back of words exercise, or where the vectors are converted into a back of words and we try to combine similar words into one. And if you want to look at similarity between text, we can go use the distance matrix.
So why do you think text data is very important? I mean, of course, numerical data brings more value, but what is it that the numerical data lacks the text data is able to bring? Could you give some examples around that?
Oh, well, the application where text data made more sense than using numerical data. I mean, let's say, again, going back to the example of an e-commerce website. So for each of the product which is on sale, most of the times the customers leave their reviews down. So, I mean, I cannot get a meaningful information about the quality of the product or how the customers are perceiving the product using numerical data. Well, one way to look at numerical data and see if the product is good or not is dependent on the number of sales which the product is making against the number of customers who are visiting the page. That's where the numerical data stops in identifying how well my product is perceived. However, if I'm looking at the reviews, which is essentially text of lines and lines of text, if I'm able to kind of build a sentiment or a classifier of that particular text into positive or negative and identify which are the words which are creating an impact and build a word cloud, I can get more meaningful info about how my particular product is performing. That's one classic case of where text data actually outperforms numerical data.
Thank you, Ravi. Thank you for joining, and maybe I'll do a deep dive into text pre-processing, and it will be really great to see how and hear many examples from you and possibly some hands-on tutorials in Python as well. So thank you, Ravi, for that. So let's continue with the lecture and let's start with text pre-processing.